Okay. Good morning, all. In previous lecture, we have started discussion related to the tool steels, and that we have seen the brief classification of the tool steels, and from that, tool steels are classified in four types. That is cold work tool steel, then hot work tool steel, and high speed tool steels, and special purpose tool steels. Out of that, one type that is cold work tool steel, and its subtypes we have studied in previous lecture. Cold work tool steel and its four subtypes we have studied in the previous lecture. Now, in this lecture, we will see what are the different types of the hot work tool steels, high speed tool steel, and some special purpose tool steels. Okay. Now, first, the slide you can clearly see that the hot work tool steels are there, and these hot work tool steels are denoted by H series. Commonly, all three types are denoted by H series only. Now, before going in the brief classification, first you should able to understand that what are the hot work tool steels. Now, this classification is done on the basis of for which work we are using these types of the uh, steels. Generally, all are used for making of the tools which we are using for different kind of applications in the manufacturing field. Now, the cold work tool steels, already we have discussed it on this point. That is, the cold work tool steels are used for doing the cold working operations for different metals or for different alloys. And the hot work tool steels are used for doing the hot working of the different metals. Now, what is the difference between cold work and hot work? The the process which is carried out below recrystallization temperature, that will be termed as cold working process, and the process which is carried out below recrystallization temperature and just below sorry, above recrystallization temperature and just below the melting point of that particular metal or alloy, that will be termed as the hot working process. Now, the steels which are used for making the different tools which are used in these processes, it may be dies or it may be different tools for which means which we are using for doing removing the material like that, or doing the various operations. That type of steels will be termed as hot work tool steels. Okay. In short, you can say that the steels which are used for doing the hot working of the metals, like some operations are there, like you can say that extrusion, stamping, then drawing, hot drawing process will be there, then forming, piercing process will be there. These will be termed as hot work tool steels. Now, what are the general characteristics or properties of the hot work tool steels? Now, here, this is the very basic difference between the cold work tool steel and hot work tool steel. First difference we have already seen, that is cold work tool steels. These are used for doing generally the cold working operations, and hot work tool steels are used for doing the hot working operations for different metals or different alloys. Then cold work tool steels and hot work tool steel related to the properties. What is the difference? Here, the hot work tool steels will provide very good or high strength, toughness, hardness, and wear resistance. These properties are present in the cold work tool steel also. But what is the difference here? Cold work tool steel will provide these properties, that is the high strength, high hardness, high wear resistance at lower temperatures only. But hot work tool steels will provide all these properties, that is having the good strength, hardness, wear resistance at the elevated temperatures, means at the higher temperature ranges also. That's why we are using this for different operations for making the tools. Okay, this is the second difference. Then on the third point for this hot work tools is they have excellent resistance to the tempering or softening. It means nothing but they will provide the hard means high hardness values. They are not going to soften due to the heating at higher temperature ranges. Then the Next point is they are classified in three basic types. That is depending on the amount of principal alloying element. Number of alloying elements may be there here in hot work tool steel. Iron and carbon will be there. Iron will be base metal, carbon is alloying element, and in addition to that, another alloying elements will be there. And depending on the largest quantity of the largest present element, the naming is given as chromium type tool steel. If chromium is the principal alloying element, then that type of hot work tool steel will be termed as chromium type tool steel. If tungsten is the principal alloying element, it will be termed as tungsten type tool steel. If molybdenum is principal alloying element, then it will be termed as molybdenum type tool steel. So these are the three basic types of the hot work tool steels. Then we will see and discuss one by one. From that, we will start with the chromium type tool steel. Now the chromium type tool steel. Here you have to explain. Just first point will be your composition, then properties, and after that you have to write the applications. Okay. Now here composition is generally you can see clearly here chromium type, then tungsten type, and molybdenum type tool steel. Please write down these points. I will explain it. I will wait for 1 minute here. Okay. In chromium, now here in hot work tool steel, it has three types depending on the amount of the principal or depending on the principal alloying element. Now generally here all the hot work tool steels are medium carbon steels. Okay, you should understand this. Generally these are medium carbon steel, means carbon percentage will be within the range 0.3 to 0.6 or 0.7. Okay. These are medium carbon steels with addition of alloying elements like chromium, tungsten, molybdenum, and vanadium. Okay. Now here in the chromium type tool steel, Its composition is, you can here think, if you are not able to remember, just try to remember this composition, that is carbon is 0.35 to 0.65%. But if you are not able to remember this, it is very easy to remember that for all hot work tool steels, these are medium carbon steels, means carbon percentage will be in the range 0.3 to zero point 0.6 or zero point 0.7 max. Okay, now for chromium type tool steel, carbon content is 0.35 to 0.65. Then chromium content is in the range 3 to 7%. And in addition to the chromium, small amount of the alloying elements like tungsten, molybdenum, and vanadium may be there, depending on their types, and depending on our need, we are changing their compositions also. This is the composition for the chromium type tool steel. Then its properties here, the general properties you can write from the previous slide also. That is, they have good strength, hardness, wear resistance. These are the general properties. These general properties you can write in all three types of these hot work tool steels. Means they will provide good strength, toughness, hardness, and wear resistance at the elevated temperature, means at the higher temperatures. And the next property is, they will provide the excellent resistance to the tempering or softening at the higher temperatures. These properties you can write for all three types here. Then after this, the last point is the applications. These steels are used for manufacturing of the dyes. Now, which dyes here? As these will provide the very good resistance for the softening, or they will remain their wear resistance, hardness, and strength at the higher temperature ranges for different casting operations. To whichever dyes are used here, for that we are using this chromium type of the tool steels. And in that, specifically for aluminum and magnesium die casting dies, these are manufactured with the help of chromium type tool steel. Then again, for different for doing different types of the extrusion process, forging process, different dies are required. That dies are also manufactured with the help of this chromium type tool steel. Then some other tools which we are using, that is, some hot shears are there, then different types of the mandrels we are using, that are made up of this chromium type tool steel only. Okay, then after this, the second type here is the tungsten type tool steel. Tungsten type tool steel. Then the first point, you have to write that their composition here, carbon content, already I have explained this. That is, the carbon content will be here, you have to just simply consider the medium carbon steel. Carbon will be within the range 0.3 to zero point 0.6. Maximum 0.7 will be there in all types of the tool steels. Sorry, hot work tool steels. Okay. Now here, carbon content for tungsten type tool steel is in the range 0.3 to 0.5%. Then as tungsten here is the principal alloying element, it will be within the range 9 to 18%. And in addition to that, chromium will be there within the range 2 to 12%. But maximum quantity of tungsten will be there. That's why it is termed as the tungsten type tool steel. If chromium is present in the maximum amount, that is 12%, then tungsten will be at the higher ranges only, means more than 12%. That's why it will act as a principal alloying element. And in addition to this tungsten and chromium, small amount of molybdenum and vanadium will be there. Now, same characteristics will be there. They will provide you excellent hardness. Red hardness, nothing but the hardness which is provided at the higher temperature ranges, where metal becomes reddish in color. Reddish in color. The hardness at that temperature ranges also, it will provide you high hardness values, higher wear resistance. These are common properties for all three types of the hot work tool steel. They will provide you high strength, high hardness, high toughness, and high wear resistance at elevated temperatures or at higher temperature ranges also. Then after writing this, you have to write the applications. These are used for manufacturing of the different dummy blocks which we are using in the manufacturing industry. Then the forging dies, then punches your which we are using hot punches, then extrusion dies for brass, nickel and steel metals, or you can say that their metals and their different alloys. Okay, commonly for all three here, for all three, the common application which is very easy for very easy to recall, that all three types of these hot work tool steels are used for making of the forging dies and extrusion dies. You can write this common application, but if you are able to remember all the specific application, it will be better. But some common applications for all three are these are used for manufacturing of the extrusion dies, then forging dies. These two will be common in all. Now here specifically in tungsten type tool steels, these are used in the manufacturing of the dummy blocks, then forging dies and different hot punches, then different dies used in the extrusion process for brass, nickel, steel and their alloys, steel and different alloy steels also here. Then next is the molybdenum type tool steel. Now here the carbon content is 0.55 to 0.65. Then togetherly here amount of molybdenum, chromium, vanadium and tungsten will be approximately 14 to 20%, and whichever quantity will be present of these four elements togetherly, molybdenum will be present in the largest quantity here. That's why the name is given as molybdenum type tool steel. Okay, this is the composition and properties here. uh, Here this molybdenum type tool steel, it is having some better properties, like here vanadium will be present in little bit more amount. In the previous two cases we have used a very small amount of the vanadium and molybdenum. Here small amount of molybdenum and vanadium, you can see that small amount of molybdenum and vanadium. Here also small amount of molybdenum and vanadium, but in this case molybdenum type tool steel, here molybdenum is the principal alloying element, quantity will be more, and vanadium is also present in up to 5%, maximum 5% vanadium will be there. And due to the highest quantity of the vanadium present here, this vanadium will provide the specific property, that is here this molybdenum type tool steel will have very good shock resistance and very good resistance for the deformation also. Okay, this is the specific property here in this, that is they will provide very good shock resistance, and resistance for deformation will be very high due to presence of vanadium in the little bit higher values, or little bit in the higher quantities as compared to the chromium and tungsten type tool steel. Maximum 5% vanadium will be there. Now the next property is similar to the previous two types, that is they will provide high strength, then high temperature, toughness, and they will provide you the tempering resistance, that is the resistance for the softening also. Then the last point is the applications, that is they will used for making the different dyes which we are using in the die casting, then extrusion, then for forging operations dyes are required, or some tools which we are using in the piercing operation or in the trimming operations, some punching blades, hot shears that are used will be manufactured with the help of this molybdenum type tool steel only. Okay, so these are the three different types of the hot worked tool steel. Okay, first I have discussed is the chromium type tool steel, then tungsten type tool steel, and molybdenum type tool steel. Then after completing this, then the next point in this is high speed high speed tool steel. High speed tool steels are there. Please write down this heading here. Some mistake is there. This is not called H series. 1 minute, I'll correct it. This is high speed tool steel. So these are designated depending on their type. Okay, H series, this is the designation for the hot work tool steel. Now high speed tool steels are designated by, uh, you can see at the end of this slide, that is T series or M series. The T series also known as the W series. Okay, now this high speed tool steels. Now first you have to explain it why the name is given as high speed tool steels. Now these steels are having a specific properties, that is they maintain their high hardness at the higher temperature ranges, about 550 degrees Celsius or above that temperature also. That's why these steels can be used for doing the cutting operations, and that during the cutting operation, high heat will get generated. That's why that tool will get heated at the higher temperature ranges. So if tool is made up of this high speed tool steel, then it can sustain that high temperature ranges by providing the higher hardness required for that cutting operation. That's why these tools are used for cutting of the metals at the high speeds. Due to that only these steels are termed as high speed tool steel, because due to their high hardness at the higher temperature ranges, we are able to use these steels for cutting the metals at the with very high speeds due to their cutting ability, and they will provide you high wear resistance at the higher temperature ranges also. That's why we are using these tools for doing the various cutting operations for different metals and different alloys. That's why these tools are termed as high speed tool steels. Okay, I will repeat it again. These tool steels provide high hardness at the higher temperature ranges also, above or about 550 degrees Celsius. Hence we can use this type of tool steels for doing the cutting of the different metals and different alloys at a very high speed. That's why the name is given as high speed tool steels. Now in the properties, you can write that these steels will provide very high wear resistance, and they are having very good cutting ability even at the higher temperature ranges. Now these steels are classified depending on the principal alloying element. Again, in the same way as we have classified hot work tool steel depending on the principal alloying element, these steels, that is high speed tool steels, are classified in two types, that is tungsten high speed tool steel and molybdenum high speed tool steels. We will discuss this one by one now. Okay, so this is the first type, that is tungsten high speed tool steels. These tungsten high speed tool steels are designated or denoted by the T series or W series. Then here, now first point will be regarding the composition. Now here they contain the high amount, as we have given the name, that is tungsten high speed tool steel. Principal alloying element will be tungsten. Okay, principal alloying element will be tungsten in this case, and in the next, that is the molybdenum type, here principal alloying element will be molybdenum. You can see here high content of the molybdenum. Now here, generally the carbon percentage here, these are having high percentage of the carbon, means generally these are high carbon steels with addition of the alloying elements like tungsten, chromium, molybdenum, vanadium. Okay. Now we will discuss one by one tungsten high speed tool steel. And these in the composition you can write like this. These are high carbon steels with very high amount of tungsten and other alloying elements like chromium, vanadium, and cobalt will be there. Okay. Now these are designated by T series. Now here for writing the composition, I have taken one example from the T series. Generally, the whichever tungsten high speed tool steels are used that are from T1 grade. Uh, T1 grade. You can simply remember that this is just the designation, that is T series means tungsten high speed tools steels. Now this T1 is having some specific composition like this, that is the 0.7% carbon, then 18% tungsten, 4% chromium, and 1% vanadium. Okay, it is also known as 1841 tool steel. In short, 1841 tool steel. That is 18 will indicate the 18% tungsten, 4% chromium, and 1% vanadium. Now, properties will be common for both tungsten and molybdenum high-speed tool steel. That is, they will provide you high hardness even at higher temperature ranges at about 550 degrees Celsius, and they are having very high wear resistance and very good cutting ability. Okay, and in the applications, the different tools simply for high speed tool steels for both types, you can simply remember that different tools which we are using. Okay, the applications will be somewhat common here, different tools which we are using, that is different types of the drills, different types of the taps, different types of the reamers, different types of the milling cutters. Okay, here you can see that different types of drills, taps, reamers, milling cutters, different types of the saws, and different types of the tools which are using we are using in the lathe machines for doing different applications or different operations, and different types of the punches and drawing dies, then different types of the tools which we are using in the woodworking. All these are manufactured with the help of these high speed tool steels. It may be tungsten high speed tool steel, or it may be molybdenum high speed tool steel. Okay, properties and application point is same in the both type. Depending on our need, we can change their compositions depending on our need of the properties. Okay, now here second type. Now here molybdenum high speed tool steel. Now they contains high amount. Here you can see that these are high carbon steels for both. You can write this, these are high carbon steels, and in molybdenum type you can write that high amount of molybdenum will be there, that is principal alloying element will be molybdenum. With addition to this, tungsten, chromium, vanadium, and cobalt will be there, and these are designated by M series. And the most widely used, that is the grade M2, and it contains, that is the composition is provided here. Now this composition is given here. You can remember, try to remember it, or if you can simply write that M2 grade steel, tool steel is also fine, no problem in that. Okay, then properties and applications are same here. Okay, now the one point is here, extra element in this we have added, that is the cobalt element. Now what is the purpose of addition of this cobalt? This cobalt will provide or permits, or it will improve the cutting ability of that particular kind of the steel, and due to that it will be able to cut the material, cut the hard and very abrasive material also you can cut with help of this type of the steels due to addition of this cobalt. Okay, means this cobalt is added to improve the cutting ability, to improve the cutting ability. And what is the role of other alloying elements? Now here in both types you can see that common alloying elements are this tungsten, chromium, vanadium, and cobalt. In the second type also, tungsten, chromium, vanadium, cobalt, and this molybdenum is there. Okay, now what this cobalt will improve the cutting ability, and what others will do, the other alloying elements like tungsten, chromium, vanadium, they will form their respective carbides, and due to formation of their respective carbides, they will increase the hardness at the higher temperatures, then wear resistance at the higher temperatures, and also somewhat they will improve the cutting ability also. So this is the effect of the addition of these other alloying elements in the both type of the high speed tool steels. So these are the high speed tool steels. These are classified in two types. Tungsten high speed tool steels, designated by T series. In this, generally these are high carbon steels with addition of tungsten as a principal alloying element, and small or very significant amount of other alloying elements like chromium, vanadium, and cobalt will may be there. Then these are designated by T series. Widely used example is the T1 steel from this. Some common properties will be there. These steels are having high hardness at the higher temperature ranges, and they will provide high wear resistance and high cutting ability or very good cutting ability. Now these applications, different tools are manufactured with the help of these high speed tools. That is the different types of the drills, taps, and different reamers, different cutters which we are using in the milling operations, and different saws, different kind of the punches, and different tools which we are using on the in the lathe operations or in the woodworking operation. That tools are manufactured with the help of this tungsten high speed tool steels and molybdenum high speed tool steel also. Different kinds of the punches, drawing dies, all these can be manufactured with the help of tungsten high speed tool steels as well as with the help of molybdenum high speed tool steel. Now in the molybdenum type high speed tool steel, here principal alloying element will be molybdenum with addition to the tungsten, chromium, vanadium, and cobalt. Now here, this cobalt will improve the cutting ability of the steels, and other alloying elements like tungsten, chromium. This is the tungsten, chromium, vanadium, and molybdenum. They will form their respective carbides, and they will improve the hardness, wear resistance, and cutting ability at the higher temperature ranges also. And generally both the types will be high carbon steels with addition to these alloying elements. Okay, so this is the high speed tool steels, and its two subtypes, that is tungsten type and molybdenum type. One is designated by T series and another is designated by the M series, and some of their common properties and some of their common applications. Okay, this point is clear for all of you. Can I move towards next slide? Okay, I will move towards the next slide now. Now this is the last type of the tool steels, that is the special purpose tool steel, depending on the somewhat their spatial properties and specific applications. Here these special purpose tool steels are classified in four types. First is the shock resisting tool steel. I first tell you the name: shock resisting tool steels, and it is designated by S series. And second type is the low alloy tool steels, designated by L series. Then carbon tungsten tool steel, designated by F series. These are carbon tungsten tool steels designated by F series. And last is the mold steels, designated by P series. These are mold tool steels designated by P series. Okay, this classification is done on their special characteristics and special application. Four types are there for special purpose tool steels. Shock resisting tool steel is the first, designated by the S series. Now here, first point you have to write related to their composition. Here it contains up to 0.5% carbon, and in addition to this, this is the 0.5% carbon steel with addition of the alloying elements like manganese, chromium, silicon, and tungsten, molybdenum, and vanadium. Now here, in the properties, that silicon and molybdenum addition will increase the toughness and shock resistance. Okay, silicon and molybdenum, this will improve the shock resistance and their toughness. Okay, then other alloying elements like chromium, tungsten, vanadium, they will improve the hardness by formation of the respective carbides by reacting with the carbon at the higher temperature ranges, and due to formation of these carbides they will also provide the resistance to the softening or tempering, resistance to the softening or tempering at the higher temperature ranges also. These are some common properties. Then applications, these steels are widely used for manufacturing of the different tools like punches and chisels, then concrete breakers, then rivet sets, and different forming dies or different kinds of the shear blades. Okay, so that can be manufactured by using these shock resisting tool steels. And after this shock resisting tool steels, which are denoted by S series, the second type of the special purpose tool steel is low alloy tool steel. Okay, this is the low alloy tool steel. In this, carbon percentage will be from 0.6 to 1.4%. With here only chromium, some amount of tungsten, molybdenum, or vanadium may be there, but chromium will act as a principal alloying element here. Then in this, properties generally provided are very high resistance and high toughness due to formation of the respective carbides from that chromium, tungsten, which are present as alloying element. Now the applications for this low alloy tool steels, and these are used in the different machine parts. Okay, like R bars are there, then chucks are there in your lathe machine, then different cams, different collects are there. For that, and these steels are used, these are the special or specific application. That's why these are categorized in the special purpose tool steels as a low alloy tool steel. Whichever alloying elements are there, carbon is there, Fe and carbon. Okay, these are steels, 0.6 to 1.4% carbon will be there. In addition to this, chromium will act as a principal alloying element, but they are not present in very higher quantity. Okay, their quantity will be smaller. That's why these are termed as low alloy tool steels, and they are having very good wear resistance and toughness. That's why they are used in the different machine parts, like different types of the chucks we are using in manufacturing of different cams or bots like that. Then some specific applications are there which require high wear resistance and toughness, and that also you can apply these low alloy tool steel designated by the L series. Then after this, the third type of the special purpose tool steel is carbon tungsten tool steel. These are denoted by the F series. For the, as far as composition is concerned, these are high carbon steels containing more than 1% carbon with addition of the tungsten as the alloying element. Okay, here in low alloy tool steel, these are also high carbon steels with addition of chromium. Okay, this is the high carbon steel only, high carbon steel with addition of chromium as alloying element. These are low alloy tool steel. And here high carbon steel with tungsten as the alloying element. Properties will be, they will provide high wear resistance, high abrasion resistance. Like this, the properties will be very similar to that of the low alloy steel. Some of the applications here for different types of the tools, that is the different types of the broaches, reamers, and then the different types of the burnishing tools are there, different types of the taps are there. For manufacturing of that, this carbon tungsten tool steels are required. Okay, means high carbon steels with addition of tungsten as alloying element, which are having very high wear resistance, high abrasion resistance, as well as higher hardness and strength. And these are used for manufacturing of different types of tools, that is broaches, reamers, taps, and burn different types of the burnishing tools. These will be termed as the carbon tungsten tool steels denoted by the F series. And after this, the last type of the special purpose tool steel is the mold tool steels designated by the P series. Now these are contain, this contains little bit lesser carbon, that is the carbon percentage will be less than 0.2, And here alloying element will be chromium and nickel, and the properties will be, and their properties will be, they will be having very high r- hardness on the surface, and inside that core will be very tough. Okay, that's why these are used for making of the molds which are used in the manufacturing of the different plastic components. Okay, different molds are required for doing the processing of the plastic materials. For that, these types of tools are used. That's why the name is given as the mold tool steels. Okay, low carbon steels with addition of chromium and nickel. Okay, in this way we have completed this point, that is the different types of the tool steels. In that we have discussed that tool steels are classified in four types, that is cold work tool steel, hot work tool steel, high speed tool steel, and special purpose tool steel. Then cold work tool steel, we have seen its four types, that is water hardening steel, then oil hardening steels, air hardening steels, and high carbon and high chromium steel. Then after that, we have discussed the different types of the hot work tool steel. In that we have seen chromium type, tungsten type, and molybdenum type hot work tool steel. Then we have discussed the high speed tool steel. In that high speed tool steel, tungsten high speed tool steel and molybdenum high speed tool steels, two types are there depending on the principal alloying element. Then the last type of tool steel is special purpose tool steel. In that we have discussed the first type of special purpose tool steel is shock resisting tool steel, denoted by S series, then low alloy tool steel denoted by L series, then carbon tungsten tool steel denoted by F series, and mold tool steel denoted by P series. In this way, this tool steel point is completed. Now, in next lecture, we will discuss about the stainless steel, why it is termed as the stainless steel, then what are the properties of the stainless steel, and what are the different types and application for that particular stainless steels, that we will discuss in the next lecture. Okay, please. And right now, I will just stop the recording. Now, in this way, I will stop here this lecture. Okay, thank you.